Turing test used to be sacred, right? It's the holy grail of computer science, right? The idea that you can't tell the difference between a conversation from a human or from a machine. And then it just so happens that we got there. And then we shrug off every LLM breakthrough as just yet another Tuesday. You guys in the room are the hardest crowd to impress. So I would like to propose something very simple called the Physical Turing Test. And the idea is like this. You host a hackathon party on a Sunday night. Your partner's yelling at you, and you're like, damn, I want to tell someone to clean up this mess and make me a very nice candlelit dinner so my partner can be happy. And then you come home to this, and you cannot tell if this was from a human or from a machine's work. But where are we now? Well, look at this humanoid robot getting ready for work. It didn't make it, right? And how about our dogs and the banana peel? So this is a data collection session at Nvidia headquarters. This is a cafe in Nvidia, and we have these humanoid robots set up where we operate them and collect the data. And how do we collect it? We have a very sophisticated way, but also very expensive way called teleoperation. And in this way, you can teach a robot what to do. But you can imagine this is a very slow and painful process, right? Basically, it doesn't scale at all. Enter simulation. We're gonna leave the physical world and then do something in simulation. And then you can build a digital twin directly, transfers, right? Zero shot. We can also apply that to much more complicated robots like the humanoid. And these humanoid robots went through 10 years worth of training in only 2 hours. And then you can transfer that to the real robot. I think we'll call this simulation 1.0, the digital twin paradigm. But the issue is you gotta build a digital twin. That's very tedious and manual. So can we start generating parts of the simulation? Do you recall this video I showed at the beginning? There's not a real pixel in this video. It is fully generated by a custom model. We take a general purpose, open source, right, state-of-the-art video generation model, and now you can prompt the model to imagine different futures. So you see these two frames are the exact same, but given different language, the generated video is actually gonna follow language and do the right thing, even though this motion never happened in the real world. This is simulation 2.0, where it's got a lot of diversity, but it could run pretty slow these days. As you scale this up, it's gonna hit a wall because the diversity is limited in this handcrafted system. And then this is the neural world models, the Sim 2.0, that's gonna scale exponentially with compute. And that's a point where the neural network outperforms a classical graphics engineer. And one day you'll come home, right, to a clean sofa and a candlelit dinner, and you wouldn't even notice the moment that we pass the physical Turing test. And that day will simply be remembered as another Tuesday. Thanks.